In this video, we are going to discuss antiderivatives and indefinite integrals. So let's start by looking at a definition of antiderivatives. Okay, let's start there. So let's say antiderivatives. All right, so antiderivatives. Okay, so let's look at a definition of antiderivatives. Definition. All right. A big letter f of x is an antiderivative of a function small letter f of x if the derivative of big letter f of x is equal to small letter f of x. So that's basically what defines an antiderivative. If the derivative of big letter f of x is equal to small letter f of x, then big letter f of x is an antiderivative of small letter f of x. That's basically the definition of an antiderivative. So, for example, let's look at this examples here. All right, for example, let's look at example 1. Okay, example 1. So let f of x be equal to sine x. All right. In 2, let f of x be equal to cos x. In 3, f of x is sec squared x. And then in 4, f of x is x squared. So let this be the case, right? So now let's quickly get the antiderivatives of these functions. Okay, let's get the antiderivatives of these functions here. Okay, let me just remove this. Quickly get this out of the way here. All right, so let's quickly find the antiderivatives of these functions here. So in example 1 here, the antiderivative of sine x, that's according to the definition of antiderivatives, the antiderivative of sine x is the function that you differentiate to get sine x. It's the function that you differentiate to get sine x. And the function you differentiate to get sine x is minus cos x. If you differentiate minus cos x, you're going to get positive sine x. So in this case, the antiderivative here is minus cos x. So you can check this. Take minus cos x, differentiate it, you will get positive sine x. And for example 2, if your f of x is cos x, your function is cos x, the antiderivative of cos x is going to be sine x, because if you differentiate sine x, you get cos x. So in this case, big letter f of x, which denotes the antiderivative, is going to be sine x, because if you differentiate sine x, you get cos x. So sine x is our antiderivative in this case. Example 3, the antiderivative in this case will be 10x. So this will be 10x, because when you differentiate 10x, you get sec squared x. And then in example 4, the antiderivative here will be x to the power 3 over 3. If you differentiate x to the power 3 over 3, you will get x squared. Okay, so that's just examples of antiderivatives. Just simple examples, but that's basically what antiderivatives are about. Okay, now there's also a theorem for antiderivatives, like an antiderivatives theorem. So let's quickly look at this theorem here. We're going to state it. Okay, we just want to quickly state this theorem. This is the theorem of antiderivatives. So I'll just put theorem and I'll put antiderivatives here. Antiderivatives. This is the theorem of antiderivatives. And what it states the following. It states that suppose that f of x is an antiderivative. So suppose that f of x is an antiderivative. Okay, let me write that in a more legible way. Suppose that f of x is an antiderivative Suppose that f of x is an antiderivative of a continuous function. Okay, so it's an antiderivative of a continuous function, small letter f of x. Okay, so suppose that big letter f of x is an antiderivative of a continuous function, small letter f of x. Suppose that's the case. Okay, then big letter g of x is an antiderivative g of x is an antiderivative of small letter f of x if and only if. That's if and only if. Now, if and only if, that's a double implication statement. If you have an if and only if, that's a double implication. All right. So we have that g of x is an antiderivative of f of x if and only if g of x is equal to big letter f of x plus a constant c, some constant c. Okay, so where c is a constant. Where c is a constant. All right, so that's basically what the theorem is. That's the theorem. That's the antiderivative theorem. Okay, a function g of x is an antiderivative of f of x if and only if g of x is equal to f of x plus a constant c. All right. Okay, so if you have an antiderivative of a function already, you have the antiderivative. To generate another antiderivative, you take that function, that antiderivative that you have, add a constant, then that's a new antiderivative. So that's basically what this thing is saying, is that if you have an antiderivative of a function already, then another antiderivative of the same function has to have that form. Okay, another function g of x, for it to be an antiderivative, it has to equal to the antiderivative that you have already plus a constant, basically. That's what this is saying. Okay. So we're not going to prove it. We're just going to leave it there. Okay. We must just know it. Okay. We're not going to prove it, but we must know it. Now we are going to move on to the discussion of indefinite integrals. Indefinite integrals. Okay, so let's look at a definition of indefinite integrals. Let's look at a definition of an indefinite integral. So an indefinite integral of a function is basically, or what it does, it basically gives you the antiderivative of that function. So an indefinite integral gives you the antiderivative of that function. So if I'm integrating this, okay, this is how I write an indefinite integral. The indefinite integral of a function f of x with respect to x is equal to big letter f of x plus an arbitrary constant c, where, of course, the derivative with respect to x, because we're integrating with respect to x, where the derivative with respect to x of f of x plus c is equal to small letter f of x. So that's basically what an antiderivative does. That's basically what an indefinite integral does. An indefinite integral gives you the antiderivative of the function that you're integrating. So the indefinite integral of f of x with respect to x is equal to big letter f of x plus c, where big letter f of x plus c is the antiderivative of small letter f of x. So when you differentiate big letter f of x plus c with respect to x, you get small letter f of x. Okay, so that's basically a definition of indefinite integrals. That's what indefinite integrals do. They give you the antiderivative of the function that you're integrating. All right. So let's look at a small example. So over here, if we're integrating some constants 7, okay, so we're integrating a constant 7, or the number 7, and we're integrating it with respect to c indefinitely. So we're finding the indefinite integral of 7 with respect to c. Now, obviously, we want the antiderivative, okay, of 7. We want the function that when we differentiate this function, we get 7. And that is equal to 7x plus an arbitrary constant c. And indeed, if we go and differentiate with respect to x, if we go and differentiate this 7x plus a constant c, we're gonna differentiate with respect to x. We're gonna differentiate 7x plus the derivative of c, the constant c. So now we're doing the derivative. We're differentiating. Now, if you differentiate 7x, obviously you're going to take the constant out. So the constant comes out because it's constant with respect to the derivative, and we're going to be left with dx with respect to x. So differentiating x with respect to x plus 0, because when you're differentiating a constant, you get 0. So obviously this is equal to now 7 multiplied by 1, because dx is 1. So this is basically just 7. So when we differentiate 7x plus c, we get back 7. Okay, so therefore 7x plus c is indeed our antiderivative of 7. So that's just basically what indefinite integrals do. They give you the antiderivative of the function that you are integrating. So indefinite integrals give you the antiderivative of the function that you are integrating. Okay, that's how they work. Now, let's move on to the next thing. Okay, so let's look at the following now. Let's look at integrating functions of the following form. Okay, so we're going to look at integrating functions of form ax to the power n. So basically, we are looking at the integrals. We are looking at the integrals of power functions. Okay, so we're integrating functions of form ax to the power n. Integrating functions of form ax to the power n. Let's look at those integrals. So now, if you're integrating such a function, so if you're integrating, this is of course indefinite integrals. If you're integrating ax to the n with respect to x, that over there is equal to the following. It's equal to ax to the n plus 1 over n plus 1 plus an arbitrary constant c. Okay, so that's what you get. So this is basically the formula for this. So there's a formula for this. If you're integrating ax to the n with respect to x, that's equal to ax to the n plus 1 over n plus 1 plus an arbitrary constant c. Okay, that's basically what it is. So let's look at examples of where you apply this formula. Okay, let's look at examples of where you apply this formula. Okay, so let's look at example 1. Okay, example 1. Suppose we have this. Okay, we have the integral of 3x to the 4 with respect to x. Okay, so we're integrating this. That's example 1. Example 2, let's integrate 2 over x squared with respect to x. Okay, example 3, let's integrate the square root of x with respect to x. Example 4, let's integrate a constant like we did before, a constant 8 with respect to x. And 5, let's integrate the function 2x squared plus 3x minus 5. Let's integrate that with respect to x. Okay, so let's look at these examples here. Let's look at these examples here. Of course, we are going to apply this formula. Okay, that we just looked at. We're going to apply that formula. So let's look at the solutions now. I'm going to write solutions here. We're going to look at the solutions over here. So let's start with the first one. Number 1. Okay, number 1, we're integrating 3x to the power 4 with respect to x. Okay, so number 1, we've got the integral of 3x to the power 4 with respect to x. So applying the formula, just as it is. In this case, of course, a is 3, all right, n is 4. So this will be 3x to the 4 plus 1 over 4 plus 1 plus an arbitrary constant c, all right? So this is basically equal to, if you simplify it, it's 3 over 5 multiplied by x to the power 5 plus this arbitrary constant c. That's the answer for that one. And the second one, number 2, we are integrating 2 over x squared with respect to x. So in this case, first thing you're going to do, you're going to write it as a power function in the standard form. So you're going to write it like this. You're going to go 2 multiplied by x to the minus 2 with respect to x. Okay, you're going to do that first. So now you go ahead and apply the formula. You go 2x to the minus 2 plus 1. You divide this by minus 2 plus 1 plus an arbitrary constant c. Okay, so you go ahead and you simplify this. You go 2. This is going to be 2 to the 2x to the minus 1 over minus 1 plus c. Okay, so this is basically just a minus 2 over x plus c. Okay, that's the final answer for that one. Okay, let's look at the next one. Number 3. Number 3, we are integrating the square root of x with respect to x. Again, we have to write this in standard form first. So we're going to write it as the integral of x to the power of half, because the square root of x is the same thing as x to the power half with respect to x. And we go ahead and we apply the formula. So that's basically x to the half plus 1. And we divide this, of course, by half plus 1 plus the arbitrary constant c equals to. Now you add this 2 and you're going to get 3 over 2. So this is going to be x to the 3 over 2 divided by 3 over 2 plus c. Okay, so you can rewrite this as 2x to the 3 over 2 over 3 plus the arbitrary constant c. Okay, and then example 4, we are integrating the constant 8 with respect to x. Obviously, this is just going to be 8x plus the arbitrary constant c. Okay, and then the last example, we are integrating 2 x squared plus 3x minus 5. And we're integrating this with respect to x. So we're going to, obviously the integral of the sum is the sum of the integrals. So this is going to be the integral of 2x squared with respect to x plus the integral of 3x with respect to x minus the integral of 5 with respect to x. So this is equal to the following. This is now going to equal to, now we apply the formula. So it's 2x 2 plus 1 over 2 plus 1 plus, then we do this one, it's 3x to the 1 plus 1 over 1 plus 1 minus 5x plus c. So in this case, we're going to add the c obviously at the end. So there we go. So we've simplified. So now we have 2 over 3. Okay, so let's write the 3 again. It's 2 over 3 multiplied by x to the 3 plus 3 over 2 multiplied by x to the power 2 minus 5x plus c. So that's the answer for this one. So this is how you approach it. This is how you apply this formula for integrating power functions. Okay. Now let's move on. Let's look at more examples. Okay, let's look at more examples. So now we're going to look at more examples. Let's see. Okay, let's look at more examples here. Let's do more examples. More examples. Okay. Now let's look at example A here. Okay. Let's look at when we're integrating the function 2x to the power 3 minus 3x, and we divide this by 4x with respect to x. Okay, let's look at this example here. Okay, what do we get in this case? All right, now let's look at also the integral of when we have 1 minus t to the power of 2 with respect to t, right? What do we get there in that case? And also the integral of, let's say we have 4 cos of 3x with respect to x. Okay, so we have a function of that nature. And then lastly, let's look at the situation where we have integral of 5 sine of 2t with respect to t. What do we get in that situation? So let's solve these examples here. So let's look at the solutions now. Let's look at the solutions of these examples and see what we get there. So let's look at solution A. Let's go back, sorry. Let's look at the solution. Okay, let me go back there. Sorry. Let's look at the solution for A, for the first integral, for integral A. So let's look at the solution for A. Okay, A. So in A, we're integrating 2x cubed minus 3x over 4x. Okay, with respect to x. Okay, so what is this equal to? In this case, what you do, you're going to divide the 4x into each of these terms here. So you simplify it in that way. You divide 4x into each term there, meaning you will have the following. You will have this. You say 2x cubed divided by 4x, okay, minus 3x divided by 4x. So you divide 4x into each of those terms there. And then you simplify what you have. So you've got the 2 cancels out with 4. So you have a 2 at the bottom. And the x cubed cancels out with x. So now you have the following. So now you have, you've got x squared. You have x squared at the top, because you cancelled out with the x at the bottom. And then at the bottom, you're going to have 2, because you cancel out the 2 at the 2 at the bottom with the 2 at the top. And then you got minus, the x's here will cancel out. Now you got minus 3 over 4 with respect to x. So you simplify it in that way, and then you go ahead and you integrate. So now you're going to integrate each term. You're going to integrate x squared over 2 with respect to x minus the integral of 3 over 4 with respect to x. So you're going to do it like this. And then you're going to go ahead, you can now apply that formula. So that formula says that, okay, you're going to have half multiplied by x to the 2 plus 1 over 2 plus 1 minus 3 over 4, because 3 over 4 is a constant, so it's minus 3 over 4x, okay, plus our arbitrary constant c, okay? So you go ahead and you simplify this. So you're going to basically have a half, you're going to have a half multiplied by x to the 3 over 3. Now the 2 times 3 will multiply out to give you 6. So you can just write that as, you can just write 6 over there. So let's just write 6 over there, all right? Because we multiply the half and the third. So we get, we basically get x to the power of 3 over 6 minus 3 over 4x plus c. So that's the final answer for the first example here. And then the next example, that's B. Over here, okay, sorry, our next example B, okay, we have the following. Okay, we are integrating 1 minus t to the power 2 with respect to t. So the first thing we do with this one, obviously, we want to simplify this. So we are going to expand the 1 minus t to the power 2. We expand this. So when we expand this, we're going to get 1. We're going to get minus 2t. And we're going to get plus t squared with respect to t. So we expand it. So after expanding it, we're going to integrate each term. Integrate 1 with respect to t minus the integral of 2t with respect to t plus the integral of t squared with respect to t. So we go ahead and we integrate this. So the first one, the integral of 1 with respect to t is just t. All right? We minus 2t to the power of 1 plus 1 divided by 1 plus 1. Okay? We apply that formula to that. And then we go plus, again, we apply the formula, the power function formula, and we get t 2 plus 1 over 2 plus 1 plus our arbitrary constant c. Okay, when we go ahead and we simplify this, so we have t, we've got minus 2t to the power of 2 over 2. So obviously here the 2's will cancel out. And then we've got plus t to the 3 over 3 plus our arbitrary constant c. So this is basically t minus t squared, because this 2's cancel out, minus t squared plus t cubed over 3 plus c. So that's the final answer for this particular integral. And then we go ahead to the next example, example C. Now in example C, we are integrating 4 cos 3x with respect to x, right? We're integrating 4 multiplied by cos 3x with respect to x. Now for this one, we are going to apply we are going to apply one of the formulas in the formula sheet. So for this one, look in the formula. You can use substitution here. Okay, you don't have to go look at the formula, but I think it's quicker to go to look at the formula sheet. It's quicker and easier. But obviously you can go ahead and you do the substitution rule to get the solution for this. Or you can go look at the formula sheet and look at the formula that corresponds to this integral. Now, with the formula that corresponds to this integral, first of all, you're going to do the following. You take out the 4 because the 4 is a constant. So you take this out because it's a constant. Take it out of the integral. So this is going to give you 4 multiplied by the integral of cos of 3x with respect to x. So it's going to give you this. And then you go ahead and you say 4. Okay, you say 4 multiplied by the following. You go look at the formula now. You go look at the formula that corresponds to the integral of cos ax with respect to x. Okay, and what it says is that this is equal to 1 over 3 sine of 3x plus an arbitrary constant c. So this is basically just 4 over 3 multiplied by sine of 3x plus c. All right, that's basically what it is. You just use the formula sheet or the substitution rule, but I suggest you just look at the formula sheet and just quickly do it like this. So, and then for d, we're integrating 5 multiplied by sine 2t with respect to t. Same thing with this integral. Okay, you're going to take out the 5 because it's constant, multiply that by the integral of sine of 2t with respect to t. Okay, and then you go look at the formula sheet that corresponds. You go look at the formula sheet and find the formula that corresponds to this integral. So you're going to get 5, the constant outside, multiplied, and then you go see in the formula sheet this integral. It's equal to the following. It's equal to minus 1 over 2 multiplied by cos 2t plus an arbitrary constant c. So it's 5 multiplied by this minus half cos 2t. So you multiply that and you get minus 5 over 2 multiplied by cos of 2t plus c. So that's basically what you get for this one. So now this completes our solutions for these examples, and this basically completes our discussion in this video. So we stop there.